Okay, so we're going to graph our primary trig functions, sine and cos specifically, and do some transformations with those trig functions. But first of all, we have to take a look at our general function for y is equal to the sine of theta. So we're going to look at how this graph actually develops. And we're going to go back to the unit circle to come up with this development of this graph. So if you remember our unit circle here, we talked about a circle with radius 1, and a circle with radius 1 is going to go through this point at an angle of 0 radians or 0 degrees. We're going to be talking in radians. It's going to go through the point of 1 for x and 0 for y. And then up here, it's going to go through the point at 0 for x and 1 for y. And over here, -1 for x and 0 for y, and down here 0 for x, -1 for y. And if you remember the angles in radians, if I go a halfway around my circle, this is going to give me pi radians. So half of halfway is going to give me pi on 2 radians. It's going to get me up to here. So if that's pi on 2, and this is 2 pi on 2, then this has to be at the bottom, 3 pi on 2 radians. And then this is going to be our 0 radians and our 2 pi radians. And then we're going to keep going around our unit circle that way. Okay, so if you remember, when we're talking about the sine function, sine were our up and down guys. So in other words, sine deals with the y values of our points around our unit circle. So that means at 0 radians, so when my angle is at 0 radians, then my sine value, my y guy, is also at 0. So it's going to be right there. When I jump up to pi on 2 radians, so I'm just going to mark that because that's the angle I'm talking about, because this is my theta axis. When I jump up to pi on 2 radians, my y guy is at a value of 1. When I'm over here at pi radians, way over here, the y guy is at 0. And when I'm at 3 pi on 2 radians, my y guy is at -1. So this is down here at -1. So we're down at the bottom. And then when I come all the way back around to 2 pi radians, 2 pi, then I'm back up here on the axis of curve. So the sine function starts on the axis of curve and ends on the axis of curve, and that's one complete period. So one complete period is 2 pi radians. Starts on the axis of curve, goes up to a max, back to the axis of curve, down to a min, and back to the axis of curve. Okay, let's compare that to our cosine function. And our cosine function, I'll do down here. So y equals cos theta. So y equals cos theta, and cos, if you remember, are the back and forth guys. Those are the x values of the points on our unit circle. So if I go to 0 radians, I look at the x values, and I'm way up here at 1. So cosine starts on its maximum. At pi on 2 radians, the x guy is at 0. At pi radians, the x guy is at -1. At 3 pi on 2 radians, we're back at 0. And at 2 pi radians, we're back up here at 1. So my cosine function starts on a maximum and ends on a maximum and has 2 zeros. My sine function has 3 zeros for each period. The cosine function also has a period of 2 pi, so that means after 2 pi it repeats again. It has the same general shape as the sine functions, just shifted a little bit. Cosine starts on a maximum, sine starts on the axis of curve. Okay, so now that we have our basic graphs of sine and cos, we're going to do some transformations of them. Okay, let's take a look at this example. Let's say we're asked to graph y equals 8 sine 3 theta minus pi on 2 plus 4 for 2 periods, so for 2 wavelengths. So we know with any transformation, what we have to do is we have to identify the a, the k, the d, and the c. But they're called different things with a trig function. We'll talk about what those are in a second. Our very first step, though, is we need to factor out this k value in front to get the actual phase shift that's going to happen. So the 8 stays the same, the sign stays the same. We factor the 3 out, and we're left with theta minus, and we're taking pi on 2 and dividing it by 3. And pi on 2 divided by 3 is the same as pi on 2 times a third. So it turns out to be pi on 6 plus 4. Okay. Now, when we're talking about transformations of trig functions, we no longer talk about a, k, d, and c values. We talk about these terms. We talk about our amplitude. We talk about our period. We talk about a phase, and we talk about a vertical shift. Okay, so the amplitude is how high above or below the axis of curve is the maximum or the minimum. The period is how long it takes to complete one cycle. The phase shift is how far did I have to move to the left or the right. And the vertical shift is how far above the regular axis of curve is my new axis of curve. So the vertical shift is how far we shifted it up. We're going to start with the vertical shift because that's going to help us out. That's one of the easiest. And we get the vertical shift by looking at this c value here, this end value, which means plus 4. So in this case, the vertical shift is going to be up 4. So that means my axis of curve that in my regular sine function occurs at right along the axis, I'm going to move it up 4. So I'm just going to put that in there right now so it helps us out. And this occurs when y equals 4. Okay, so the phase shift we get by looking here. We're looking at the d value. How am I shifting left or right? And just like we've done with all of our other transformations, a pi on 6 shift that's negative inside the bracket means a pi on 6 shift to the right. So this is going to be right pi on 6. The period we're going to come back to in just a second. The amplitude of this function is given by the a value here. So the amplitude here is going to be 8. What that means is how far above from my axis of curve and how far below on my axis of curve. So since I have an amplitude of 8, I know that my maximum is going to be 4 plus 8, which is 12. And I know that my minimum is going to be 4 minus 8, which is going to occur at negative 4. So now I have my maximums and my minimums set up. The last thing is your period. And the period is given by the regular period, which is 2 pi of a regular function, divided by whatever the k value is. So in this case, the period is going to be 2 pi divided by this k value here, which is 3. So 2 pi on 3 is going to be the period for one complete cycle. Okay, so how do we set up a graph of this function? Well, it all sort of starts with the phase shift. So the phase shift says I'm shifting over pi on 6 to the right. The next biggest step is to figure out what scale am I going to use. Do I want to go up by pi on 2s, pi's on 3s, pi's on 6s? What's the scale that I want to use? And because the phase shift is suggesting pi on 6 to the right, then I think I'm going to be going up by pi on 6s. So setting up my scale, there's 1 pi on 6, 2 pi on 6, but let's write that reduced. So 2 pi on 6 is pi on 3. 3 pi on 6, let's think of that reduced. That's going to be pi on 2. 4 pi on 6, which is 2 pi on 3. And we keep going. 5 pi on 6, we can't reduce. 6 pi on 6, which is just pi. 7 pi on 6. 8 pi on 6, which is 4 pi on 3. 9 pi on 6, which is 3 pi on 2. 10 pi on 6, which is 5 pi on 3, 11 pi on 6, and we'll stop there. Okay? All right, I'm just going to switch colors to make this easier to look at. All right, so the next step is I go, okay, so my graph is going to start pi on 6 to the right. What kind of graph am I looking at? I'm looking at a sine graph. Because I'm looking at a sine graph, when we go back up here to the original sine function, I go, hey, sine started on the axis of curve. So I'm going to keep that same pattern with my graph, and I'm going to start sine on my axis of curve. The next thing is the period. So I know that my graph's going to end, or my first period is going to end 2 pi on 3 after I started. Well, 2 pi on 3, just because we're going up by pi on 6s, is the same as 4 pi on 6. So I know from where I start, if I count up 4 pi on 6s, that's going to be the end of my first cycle. So here's my starting point. There's 1 pi on 6, 2 pi on 6, 3 pi on 6, 4 pi on 6. So that's the end of my first cycle. What that also tells me is, or what this helps me with, is based on our original sine graph, we also had a 0, or we also crossed the axis of curve halfway in between the starting and the ending of my period. So halfway in between is going to be pi on 2. And then halfway in between the 2 points on my axis of curve is going to be my maximum. So at pi on 3, we're going to be way up here at 12. And then halfway in between this set is my minimum, and I'm going to be way down here at -4. And this follows the same pattern as my original, except I've got some transformations occurring. So that completes one cycle of this function, but I said we want to go 2 periods. So now I just repeat the pattern, and it looks like every pi on 6, I'm going to be either going to a maximum, a minimum, or back to the axis of curve. So now that I'm on the axis of curve, I'm going to go back up to a maximum here at pi, back to the axis of curve, down to the minimum at 4 pi on 3, and then back to the axis of curve at 3 pi on 2. So then I just complete that. And now I've completed 2 cycles. Double check, make sure your amplitude is 8. So there's 8 between the axis of curve and how far up I go, and 8 between the axis of curve and how far down. My period is 2 pi on 3, and then I repeat again. I've gone right pi on 6, and I have a vertical shift up of 4 on my axis of curve. And that is how we're going to graph transformations of sine functions. If, for example, the transformation gave this as a cosine function, then the only difference is that you would start on a maximum at pi on 6 as opposed to on the axis of curve.